Okay, so I think we can get this all done for the last set of videos here. So if we have direct substitution, go ahead and do that. And when you substitute, you can go ahead and just replace. And this is perfectly fine as long as it's defined and continuous. And basically it's just, are you dividing by 0? That's the main thing, or the square root of a negative would be an issue. Natural log of e, you should know, cancels out as 1, and 2e is nothing special, just leave it like that. So direct substitution there. If we look at the next one, this is continuous everywhere. So as you plug in 5, 2/5 times 5 squared, don't worry that says 5 from the left side because it's continuous, plus 2 times 5. And let's see, 5 squared is 25, divided by 5 is 5 times 2 is 10, plus 10 is 20. I guess I should double check my math along the way. And you should also be checking my math because I am notorious for making arithmetic mistakes. This makes me nervous in case you forgot sine, cosine over the summer. Just remember where pi is on the unit circle. It's over here. Ordered pair is -1, 0. So sine of 0 is 0. And then cosine of 0 is, cosine of pi is -1. I guess I should also write squared because this is 0 squared. But anyway, 0 squared is 0 minus 2. Here's another that if you aren't good with the unit circle, we have some work to be done. 5 pi over 3 is in the 4th quadrant. That's the ordered pair 1/2, root 3 over 2. And tangent is sine over cosine, so root 3 over 2 over 1/2. The 2's will cancel. So we're looking at root 3 over 5 pi over 3 squared, because we can plug both those in for alpha. So what are we looking at? Root 3 divided by a fraction is the same as multiplying by the reciprocal. 3 squared is 9, 5 squared is 25, pi squared is just pi squared. Yeah, nothing to work. And all I would do is move that root 3 into the numerator. All right. So I'm just going to leave it like this. I would just rewrite the problem if you're curious. Now if we look at this problem, we're finally at an issue because if we plug in -2 into the denominator, we're dividing by 0. So now we need to rewrite the limit as x approaches -2 and actually factor the numerator and denominator. So as we factor the numerator, factors of -6 that add to be -1 would be -3 plus 2. X and x, and the denominator doesn't look, it is factorable, you're just factoring greatest common factor 2 out. So as we're looking at that, I can change colors for you, we can cancel out the x plus 2, and now we can plug in -2 into that problem. -2 minus 3 is -5, and there's a 2 in the denominator, and that is it. So moving forward with the next one, again, we're running into an issue where if we put 3 into the numerator and denominator, we're going to get 3 squared is 9 minus 9. We're going to be dividing by 0. So as we do this problem, and we try to factor, can't factor the numerator, and the denominator is a difference of squares, x plus 3, x minus 3. Well, nothing cancels. And since this is not like to the, from the left side or from the right side, it's just a straight limit. I was trying to get rid of that. Basically what we have is we have a vertical asymptote at both 3 and -3. And because we're looking at 3, and on one side, I'm not sure which one is going up and which one's going down, you can't even state a behavior in this graph. All we can say is that the limit does not exist. All right. Looking at the next one, same thing as we have an issue because if we plug in 3 has into the denominator, we're dividing by 0. And if you notice, the numerator is actually a difference of cubes. This is why they make you learn sum and difference of cubes and all those factoring techniques before this class, where the cube root of 8 is 2, the cube root of x cubed is x, the cube root of 27 is 3, and then what's everything else is the 2x being squared, so that's 4x squared, the opposite sign, so plus, you multiply 2x times 3, which is 6x, and then this last one is 3 squared, so plus 9. And if you notice, the denominators will actually cancel now. And this is actually really nice. I've already worked it out. When you plug in 3 halves and for this x's, you end up getting 9 plus 9 plus 9. And you can just trust me on this one or double check my math to get 27. I'm trying to make sure that my video is done because I've already made 2 videos at this point. I want to make sure I get this done. Here's another issue. You're going to be dividing by 0, so this is that rationalizing technique where you're multiplying by 2x plus 5. The radical is the same, but then you change it to be plus 1. That way, they will cancel. And you have to multiply the denominator by the same thing. So as we FOIL the numerator, don't forget to write the limit as x approaches -2. Those pieces will cancel. The square roots cancel, the outside and the inside term cancels, and then you get -1. In the denominator, you still have x plus 2, but then you have this other piece of the square root of 2x plus 5 plus 1. And let me just write it right here, that 2x plus 5 minus 1 is the same thing as factoring out a 2. So let me cross this off for a second. And 5 minus 1 is 4. And as I factor out a 2, it's going to be x plus 2, and I think you can see right there, that's where we are going with this. Now we can plug in -2 into all these problems. I'm already tired. So we have a 2 on top. 2 times -2 is -4, plus 5 is 1. The square root of 1 is 1, plus 1. So 2 divided by 2 is 1, is this limit. And we have another rationalizing technique here for letter I. By the way, don't forget, this is a video. You can pause at any point, and you can go back, and you can try and see if if you get lost or if I'm going too fast. Just make sure you learn from this. So as I FOIL the numerator, 1 times 1 is 1. That's a 1 right there, by the way. The outside and inside terms cancel. One's negative and one's positive. And then the square roots will cancel. Now be careful because it's a negative times a positive, so it's negative of that quantity, 2x squared minus 1. And that is important. Because as you distribute this in here, it becomes a 1 plus 1. So we're going to have 2 minus 2x squared, and you can factor that out. Maybe I'll write that out. I forgot to write limit. Limit as x approaches 1. So 2 minus 2x squared. And the denominator is the same. I'm just trying to save some time. A good math student would write that out. Limit as x approaches 1. And I'm going to factor out a -2. That way it looks like x squared minus 1. Again, a good math student would rewrite all that out. The point I'm trying to get out, though, is that you have a difference of squares in the numerator, x plus 1, x minus 1, to eventually cancel out with that x minus 1 that you had in the denominator. Minus 1 there. And let me just switch over to this color. X minus 1s will cancel. We can plug in 1. So in the numerator, you get -2 times 2. Over in the denominator, 1 squared, 2 minus 1 is 1, square root of 1 is 1, plus 1 is 2, and cancel one of those out, and you're left with negative 2. There you go. A few more, again, plugging in 0. Now, if I were doing this problem, I would not really try. I would just simplify this. And what am I talking about here is if you're dividing by a monomial, you can just stick that into the denominator. 1 over x plus 2 plus 1 over x squared. I hope that makes sense. Please let me know if you're confused with that. So now you can get this to be one denominator. So that's the limit as x approaches 0. Common denominator being x squared, x plus 2. So this piece is missing an x. This piece is missing x plus 2. So what we have is the limit as x approaches 0 of 2x plus 2 over x squared, x plus 2. Oh, I'm looking at this and nothing cancels. So this is one of those does not exist still. Even though we were able to do some math, it didn't cancel anywhere. So we're going to get to does not exist. Looking at k, again, I'm kind of in a hurry to make sure that we can get all this done in this video. X approaches 2 on the right side. We can definitely factor the denominator as a difference of squares. Let's see, the top looks like it's factorable because you can get 3x times x to give you 3x squared. Let's see, 2 times 1. There you go, 6x plus 1. If you're not very good at factoring, you can definitely pause the video and do it your own way, but this does check out. So now I can plug in 2. So 3 times 2 is 6, plus 1 is 7 on top. Let's see, we get a 0 on bottom, so this is our clue that it's going to be it does not exist. So you don't want to write that it equals that because that's not true. But now that we have from the right side, we can approximate, we can state the behavior. So if we do that, we would get a positive in the top, like I'm doing 2.1, still a positive on top. 2.1 minus 2 is a positive on bottom. So this is telling me that the behavior will be a positive answer or go to infinity. But I will accept does not exist as well, but there is this behavior of going up to infinity. And then I believe this is the last two before you're ready for your homework. And again, they're the same problem. So nothing cancels, non-canceling in the denominator. So you can say, okay, we want a number slightly bigger than 3. Well, slightly bigger than 3 gives you a positive on top. Slightly bigger than 3 minus 3 is still positive. So we know that even though it does not exist, the behavior goes to infinity. But I will accept does not exist because that is technically true. And then this last one, just change colors. A little bit smaller than 3, so like 2.9. Well, 2 times 2.9 plus 5 is still positive. But 2.9 minus 3 is a negative. So this is definitely the behavior of negative infinity or does not exist. So be ready to give both those answers if it shows up on a test, especially a multiple choice. I could give one or the other, and I expect the best answer possible.